Sorry, guys. Okay. See, I could see a couple of people having problem with few installation. Let's probably try to address that initially. Where is that? Let me go to the group. Okay. Anybody having any issue that you want to discuss? I saw few people um, mentioning about errors in setting up the database and setting up the service. Anybody wanted to probably discuss on that, or if you guys are okay?
Satish, I'm trying to install MySQL. Right now, I'm on the screen, I think it'll take a lot of time. I can share.
Oh, okay, then fine.
Yeah,
Then good. Okay, no problem.
maybe we can look at it at the end of the session.
That's okay. Yeah, sure. So fine. Now, today we'll spend some time on as per the schedule, right? We will get started with the basics of Java and JVM. Okay. So I was telling you about the installing Java in your machine, right? The JDK. Structurally, how the structure would be when you install Java, right? You will have JDK. JDK is your Java development kit, correct? And then inside JDK, you will have JRE, which is a Java runtime environment, which it then will contain your JVM and your class libraries. Okay. Um, Probably what you can, if you want to probably compare or understand this, right? Even in LoadRunner, if you see, there are multiple components. For scripting alone, you need Vuegen. If you want to execute the script, then you might need load generator and controller, right? Similarly, in Java as well, if you want to run the application alone, say for example, if you want to install Tomcat and then run the application, or if you want to open Jmeter. So as an end user, if you're going to use Java-based application, then you just need the Java runtime environment. Okay, because you're just going to run your Java in that environment, so you just need a JRE. But if you want to develop application, do a compilation, debugging, then you need an entire Java development kit, okay, JDK. Okay, so in many of your production environment, your testing environment, you will have your JREs. Okay, but more from a development angle, you will have an entire JDK. Okay, now even if you go to your the path where Java is installed, you go to see program files, Java and JDK. And in JDK, if you go to bin, if you go, this is your folder where you will have java.exe, right? You have java.exe, and then you will have other utilities like Java C, JStat, JConsole, uh, all these different utilities, JMap, right? To take thread dumps, to take heap dumps, to monitor your Java heap, or you will have a lot of command line tools here. And if you go to server, you will see jvm.dll. Okay, so that's how your JDK will be there in JDK is a complete kit for both for development and which will also have your Java runtime environment. Okay, and as I mentioned yesterday, you for your art training or learning purpose, you can install the entire Java, entire JDK, and then you can set up your environmental variables as I was showing you yesterday while checking your Java version. If Java version is not getting reflected, check the environmental variables and set it. Okay, yeah. Now, when it comes to JVM, right, we'll spend a lot of time in memory later, but at a high level, when it comes to your JVM, okay, it is going to have two components. One is your memory component. Second is going to be your execution component. Okay, one which is going to take care of the execution of your Java code, and another one is it is going to store all the temporary variables that your execution needs in your JVM memory. Okay, there's something called class loader, which is not of much importance for us. It is more of loading all the your programs, system libraries, system classes into the JVM. That's what class loader is. Okay, and it's not that important from a performance engineering or even from a development aspect as well. I mean, people are not even going to aware there's something called class loader. Okay, but from a component perspective, there's going to be a class loader. Second is our important JVM memory. Okay, so obviously for any programming language or for any software, you need a runtime memory, right? Simple addition A plus B equal to C, right? You need to declare a variable A, declare a variable B, declare a variable C, and in the runtime, A will have say number 5, B will have number 3, C will be number 8. So temporarily, it is going to store these variables and the values in the memory, right? That's why you need a memory. Okay, and in JVM memory, you have 5 subcomponents. Okay, to store different things, they have different components. Okay, and in that JVM memory, your heap and stack. Okay, heap and stack are 2 important components that we will be learning a lot in the upcoming sessions. Okay, now so in Java, um, we have 2 types of data types. Okay, one is primitive and another one is non-primitive. Okay, let's not go too technical with this jargons. Okay, to keep it simple. Okay, all these small variables like your integer, character, boolean, which are very small in nature, will be stored in your stack. Okay, all your strings, arrays, objects which are going to hold more amount of data, or where the size of the variable is going to be huge, it will get stored in the heap. Okay, and in technical jargons, we call it as a primitive data type. All this integer, character, long, which is going to get stored in the stack, and the non-primitive data types like strings and arrays are going to get stored in your heap. Okay, and then I will come to in detail about the difference of stack and heap, how it is related to a garbage collection. All these things we will, when we go into a memory topic, we will look into it in detail. But for now, what you can remember is in JVM memory, there are going to be 2 important components, heap and stack. In a program, you will typically declare integers, characters, booleans, strings, arrays, and you create objects, right? When that happens, the integers, character, and boolean will go and sit inside your stack. Okay, and then your strings, arrays, and everything will go and sit in your heap. There is one more thing called metaspace. If you see here, there's something called method area, which is nothing but a metaspace. Okay, whatever static data that you declare. Okay, if you declare a string as a static, or if you declare array as a static, okay, that will go and sit inside your metaspace. Okay, all the reference to the static variable will go and sit inside your metaspace. Okay, and additionally, metaspace also will store some of the metadata of your classes. Okay, as the name mentions, metaspaces, it is going to hold a metadata about all the your classes, plus it is going to store the um, one second. Is my screen visible, by the way?
No, we are still seeing the first screen JVM architecture.
Okay. One second. Yeah, I didn't move anyway, but just want to make sure, because in my mobile I couldn't able to see the screen. That's why I thought I'll ask. Okay, fine. So yeah, so the meta space, heap, and stacks, these are the three sub component of the JVM memory. And then other tools are going to be something called PC register. PC register is going to hold the information about the thread execution. Okay, what methods or what steps are getting currently executed. So as a name implies, right, it's a registry. It is going to keep the registry of what is happening in every thread. And all these things are all, see, apart from a heap, little bit of stack, other things we will not even worry, we will not monitor, we will not profile, we will not configure, nothing. Okay, so metaspace, PC register, native method stack, we will not even know something is there existing at all. Okay, only the heap is a component where you need to configure, you need to tune, you'll be profiling, there'll be a lot of problems, you'll be taking a heap dump, monitoring during load testing. All this will happen during your with respect to your heap. Stack also, you might be doing little bit of configuration if it is really required. Otherwise, even that is not going to be a problematic area. Okay, metaspace, no, we'll not even worry about it. Will not even monitor. PC register also will not even touch it, will not even know something called PC register exists. Same thing with your native stack as well. Native stack is something slightly different from the actual stack. Whenever your Java program is going to probably connect with your desktop programs, like it can be your say other uh, Windows softwares, or with your Python component, right? Whenever there is a connection between your Java program to those specific programs, those reference or those connections will be maintained in that native method stack. So it's a temporary area again, which is going to hold the reference of what is happening between your Java application with your that OS specific softwares, like it can be Python or it can be any other OS specific softwares. Okay, again, that we will not even worry about it. This is all theoretical stuff about your JVM architecture. Okay, so JVM architecture, JVM memory is going to be one of the important component in that. Heap is the only area which you will be learning a lot, and which is actually required as well from a engineering perspective. Okay, and then the next component is going to be an execution. Obviously, you create a program, you compile it, you going to run it, right? You're going to access the application directly through UI or from anywhere else. So while the Java code is getting executed, this execution engine in your JVM is going to take care of your execution. Okay, it has some couple of components here. There's something called interpreter, which is going to convert your Java Java specific compiled code to your mission understandable code. Okay, see, the Java can be run in Windows, it can be run in Linux, it can be executed in Mac, it can be executed in any other operating system, correct? So the interpreter is the one which is going to convert your Java compiled code into a mission understandable code. It will see, because Windows should know how to execute, Linux should know to execute, right? So this component will take care of that. Okay, and then there's something called garbage collection. Okay, so garbage collection, though it is going to do the cleanup work, though it is going to maintain your heap, this is part of your execution engine. Okay, garbage collector, we'll learn a lot about it. It is a software. It by nature, it by itself, it's a set of libraries. End of the day, it is a Java code in itself. Okay, it is a code by in itself, which is going to run when a JVM starts, your GC will also get started, and it will be throughout your JVM cycle. Okay, so garbage collector is part of your execution engine. Okay, there are other components like hotspot profiler, JIT compiler, which is going to maintain, which is going to actually take care of some efficiency of your execution engine. Nothing, this profiler has nothing to do with our own J profilers. Okay, this is something JVM uses in itself to efficiently operate your JVM or to execute your Java code. Okay, in this execution engine, GC is the one which we'll be learning a lot later in the days. Okay, so from a memory perspective, we will learn a lot about heap, a little bit about stack. Okay, and then a lot about garbage collection from a execution engine perspective. Okay, so as after completing your CPU profiling, response time analysis, when we go into the memory related topics, we will go and do a deep dive on the heap stack, how different it is, and how it is going to be related to a garbage collection. And we'll learn something about stack overflow error. What is that? Why it will happen? How to fix it or how to address that stack problem and all, we will learn it in detail later. Okay, just give me 1 second. Okay. Yeah. Say I was talking about the primitive, non-primitive, and class loader, right? Now, as I mentioned earlier, when we go and analyze the performance problem and troubleshoot the response time issue or a memory issue, we're going to keep talking about these terminologies, okay? Like classes, methods, objects, packages. Whatever tool you're going to use it, whatever APM tool like Dynatrace, AppDynamics, okay, what are profiling tools? End of the day, you're going to say that, okay, this problem is there. This is because this is getting originated from this class file, this method, or this method is calling another method, and this method is calling making a SQL query. That's how it is going to be. So it is very important for you to visualize or understand these terminologies, what it means by method, object, class, so that when you go and talk to the developers, you can go and talk to them with much more conviction, right? You'll know exactly what you're talking. Okay, so what I'll do is I'll explain this in a little bit of an easier way. It might not be a perfect way of explaining these, but when we go perfect, it will be a little bit of confusing as well. Okay. See, you write programs, right? Obviously, for any computation, addition or subtraction or multiplication, I mean, just considering very simple examples, right? You write programs. Okay. So which is, since we are writing in a Java, it is a Java program, correct? Now, when you compile your Java program, it becomes a class file, dot class. From dot Java, it will go into the dot class. Okay, once again. Okay, so when you write a program, you save it as a dot Java, and then when it gets compiled, it becomes a dot class file. Okay, and if you take any program, okay, any program, you're going to as I said, to even to do addition or subtraction, you need variables, correct? A plus B is equal to C, which means A has to be declared, B has to be declared, C has to be declared. Okay, A could be an integer, B could be an integer, C could be an integer. And you might need strings, you might need arrays, you might need a lot of these variables for your program to work. Temporarily store the data. Okay, your input has to be stored, your output has to be stored before it is getting published into a UI or it is getting stored in the database. Those has to be temporarily has to be stored in a program for computation. Okay, so any Java program, if you take it, it is going to have a data declared. Okay, and in there we have two data types, primitive and non-primitive. Okay, as I said, integer, byte, character, boolean, all are going to be your primitive. Strings, arrays, and objects are going to be your non-primitive. So a program, when you compile, it becomes a dot class. In an application, there will be n number of class files. And every Java program, you're going to have a data declared, integers or strings. And then the actual computation will happen inside a method. Okay, a method is a logical grouping of operation. Okay, a class file might have a different methods. Okay, say for example, again going to a calculation, addition, subtraction, multiplication, division, all these are all different methods. Okay, so logically you will have, see, when you can have everything inside one method also. It is not that it is not possible, but it is always the developers, they logically group these operation into different methods. Okay, so every program will have multiple methods. Okay, now as I said, a application will have multiple classes. A class will have multiple data declared, multiple methods. Now, since there are going to be more than one class file, right? So you can have 10 class file, 20 class files. The collection of class file will be under a package. So package is nothing but a collection of class. Okay, application will have, logically, they might have more than one or two packages. Okay, so application will have multiple packages. A package will have multiple classes. A class will have multiple methods. And then the different data that is declared inside your class. Okay, this is very common for any application, any programming language. That's how it is going to get structured. Okay, you take a small application or a huge application, all these things are still applicable. Okay, now in that there's another thing called object, which is something very confusing topic. Okay, there's a lot of definition around this object. I'll try to keep it very simple for your understanding. Okay, object as a definition, it is a instance of a class file, a duplicate of a class file. Okay, so you will have a one class file that is written and compiled and available in your JVM. Correct. Now, during a runtime, when a class is called, an instance of the class will be called. Okay, a duplicate of the class will be created, and then that instance of that object will be called during the runtime. I'll give an example. Okay, say we'll take an example of Amazon.com. Amazon.com. Okay, and in Amazon.com, we go purchase, we shop, we look for different products, and then we might need to find out the price of a product, right? Before we purchase, we need to calculate and then get a price of a particular product. Now, if you want to go and purchase a product, say a laptop, okay, and I want to go and purchase a mobile. Okay, so when you going to submit a button, say to provide me the price or calculate the price, I'm also going to do the same thing. A call will come to the request will come to your Amazon server. Okay. And then there will be class files for, say, price calculation, price calculator.java, for example, right? So it will come to the main class file. From there, it will go to the this price calculator.java. What will happen is during runtime, there will be an object that will be created for you separately for the same class file called price calculator.java. For me also, this object will be created for the price calculator.java. And then this object will get stored in the heap. All the objects will get stored in the heap. Okay. So the first object which is created for you, that will handle, okay, for you, the product is going to be a laptop. Quantity as 1. Okay. Country can be in US. Okay. So in the program, you will be declared a product as a string, quantity as an integer, country as a string, right? So for you, for the object which is got created, right? It will handle your product laptop, quantity, country, and then the methods inside the class will get executed. It will do a price calculation, and it will send the response back to your UI saying that it is, say, $1,000. For me, object which is created separately for me, there you would have declared I would have requested for a mobile, quantity as 2, country is India, right? Then it will do all this calculation, and I'll get a response saying that the product price is say 50,000 rupees. Okay, like this, in a runtime, thousands of such objects will be created, because there will be many people who will be using Amazon.com, right? For every functionality, it can be a login, it can be calculating the price, add to cart, checkout. So there's thousands of instances of a class file, which is called object, to be created in heap, and then it will, once that operation is over, right? For example, you have now done the price calculation, you saw that, then you would have moved on, right? You might be moving to purchase it, or maybe you would have closed the browser, or you would have gone to searching another product, right? Once the price calculation work is completed, the job of that object is completed. So after a few seconds, after a minute, or after a few minutes, that object will get deleted. Okay. So runtime, thousands of objects will be created, deleted, created, deleted. Okay. So that's how the life cycle of an object is going to be in your JVM. Okay. So within your Java program, or within an application, there can be n number of Java classes grouped under a package, and every class file will have multiple methods, multiple data types declared, and then a method will take care of the actual computation. And then during the runtime, instance of the class file will be created in heap, n number of objects will be created and destroyed. Okay, another example what I've given here is, say, for example, if there is a college registration or a school registration application, right? Okay, now when you want to enroll yourself or your kid or whoever it is, right? When you're going to submit a registration, correct? So name of the student can be say John, age 12, right? And then with some credentials, some details about the student, you will enter, and then you will submit it. Okay. So during a runtime, there will be an object that will be created for that registration class. Okay, exclusively to handle this John's data, to process and store this John's data into the database. Similarly for Sophia, similarly for Lily, right? When 3 registrations is going to happen in parallel, there will be 3 instances of registration classes will be created. 3 objects of that registration class will be created. And then the methods corresponding to that class file will get processed, and the data will go and get stored in your database. Okay, so that's how your the Java program is going to work. And if you go and look into any of your, say for example, our Java Eclipse in the Eclipse in your eLibrary application, right? eLibrary is my application. If I expand it, if I go to the source, okay, there are 3 packages: Java t-point.servlet, Java t-point.dabo, Java t-point.beans. Okay, and if you expand these a package will have multiple classes, right? All these are all Java programs, individual Java programs, multiple Java files clubbed under one package. And if you see every program, a compiled version of that is the class file. This is a class file. This is a class file. This is a class file. Okay. And then if you go and look into any of your class file, in that you will have a method. Okay. There's a method called openlib. Okay. And then you will have declaration like strings. And if you come down, let me take another example of this. Okay, so there is a method called populate list, clear list, and then integer. So any program will have multiple methods and then multiple data declared inside your class file. Okay, so you take a small application or a big application, that's how it's going to be arranged. A package with multiple classes. A class will have multiple methods with different data declared. Okay, and there's one more thing called import. You will see something called import as well in many of your programs. See, you are not going to write thousands of lines of code every time. Okay, to make a database connection, to make a HTTP connection, or to process a JSON file, to process a CSV file, to write something into your local storage, right? For whatever computation, whatever data processing, there are going to be already written programs. Okay, in the open source, in the Java community, there are going to be a lot of such reusable packages, reusable data, reusable Java programs that will be already available. Just that you need to import it and then have it part of your import at the top. Okay, for example, if I go to this db.java, okay, if you see, I have something called java.sql. Okay, this java.sql it's a set of code, set of libraries, which will help you to make a connection to a database, execute queries. Okay, all these things will be taken care of by this package. You will just write 3 lines of code, 5 lines of code. Say, for example, for inserting a data into a e-librarian table, you'll just be writing 5 lines of code or 6 lines of code. Right? You're not going to write underlines of code. Somebody has already written code, which you're going to import it and use it. That's how the entire the development world works, right? So in any application, in any classes, you're going to have multiple imports. Java.sql.connection, SQL.prepare statement, result set, and if you want to process JSON, there will be JSON related packages. Okay, so a program will consist of such many imports as well. Okay, now when you want to write a program on your own, okay, so to learn Java or any programming language at this time, when you said this time with your years of experience, we are not new to IT, right? We already are having experience. So going to a book and then going to topic by topic, understanding the OOPS concept, and then going to the data structure, all the conditional statements, reading it all these chapter by chapter. Number one, we will not have time. Number two, we'll get easily bored. When a lot of people, including me, have tried doing these things in the earlier stages, never worked out, right? But now the best way to do is you start writing programs. Okay, you define your own requirement, reading something from a CSV file, reading something from a JTL files, reading something from a HTML file, doing some computation, writing into a database, writing into a CSV. You create your own requirement. Okay, now with the um, uh, availability of generative AI with copilots, code companions, creating a code is something, it's not going to be that difficult at all. Okay, even without you knowing a lot, you will be able to create, compile, and run it. Okay, but here our scope is not to develop applications or to learn development here, right? It's more for us to get some hands-on. If you get hands-on, if you go and create your own programs, you will not forget it, and then you will get used to these terminologies. You will know what a developer is going to do. That's all we are trying to do here. Okay, so start creating your own small programs. Okay, be it can be a simple addition calculator programs or whatever it is. You define your own requirements and you go and create these small programs. It will be a lot fun. Okay, trust me, it is going to be a lot more fun. You will get a lot of motivation. You will get addicted as well sometimes. Okay, I'm saying it. Okay, if you have your Copilot in your laptop, okay, many of your laptops now comes with a Copilot, or you can go and register it online. There are a lot of AI websites, right? GitHub Copilot or Gemini, they offer you free licenses. Okay, though there are restrictions, for our purpose, it is going to be more than enough. Okay. What we'll do it on Monday is we'll just go and do some hands-on programming, creating few classes, multiple classes together, making a database connections, making a HTTP connections. Okay. All you need is Eclipse. Okay. Nothing more than that. So we'll just do some few hands-on on Monday, so that you'll get used to this environment. Okay, I'll pass it here. Any questions on JVM, heap, stack, this basics about Java, or anything on the installation, what we have done yesterday? Anybody have any questions? Feel free to ask.
Satish.
Yes, please.
Yeah.
Yes, please go ahead, Raj. Please.
All right. Okay. Satish, if we can go to the JVM architecture slide. So in yes, so here we have I see two stacks, right? JVM language stacks, and the other one is the native method stacks. So I was wondering where the primitive data in which of these stacks.
It will be in language JVM stack only. So all the your local integer character that already declare in your program, that will get stored in your JVM language stack.
Okay. How about the reference variables to the objects? Where is that? Where are those variables stored?
Okay. So now, since you asked this question, right? For example, integer character booleans are going to get stored in the stack. Okay. And then when there is a string, when there is an array, when there is an object, the actual strings, arrays, or objects will go and sit in the heap. Okay. Now, whenever a string or array is created, there is going to be a reference or an address that will be created for those objects. Whenever this non-primitive data is created and stored in the heap, for every object, for every string, for every array, there will be an address. There will be a reference that will be created, and that will get stored in the stack. For example, if you see this diagram, okay, there are two objects, right? One is an object, another is array, and both will have a address sitting inside a stack. Okay, so this relationship is very, very important when it comes to garbage collection and all. But as you asked, the actual object will sit in the heap. The address of that or a reference of that reference variable will sit in your JVM language stack.
Okay, so it's the JVM language stack where the reference of the primitive variables will be stored. Okay.
Hi Satish, Gokul here. So Satish, like I could not join. Like there was some drives for installation of tools, right? Is that a link in chat? If so, can you share me the link?
What is the name? Sorry.
Gokul Saronan.
Okay. Okay. I'll share the drive. Once again, let me share it in this group itself. Whoever has registered and you gave your email ID, I have given access, and you would have got an email as well to that email box. Okay.
Okay, I did not get any email. Okay, I will check.
Okay. Yeah. If you have shared your email ID, I would have given access. I got I think 2 or 3 of you have given me this email ID. I have given the access. If not, let me know.
Okay, can I ping in the session chat?
Yes, there as well. I'll ping it in the group chat as well. I've pinged in the Zoom here. Okay, I'll also ping it in the WhatsApp. Okay.
Sure. Yeah. Thank you.
Okay. And Raj, your installation is completed?
No, Satish, I can share my screen and show.
Oh, it is still going on, or is it having an issue?
Right now, it says it has downloaded all the products. I can share a screen. Shall I go ahead and share my screen?
Okay, not required, because if it is, yeah, you can continue and then complete the process. If in case you have a problem, let me know.
Okay. All right. Yeah, it's right now. It's on
like
the product configuration screen. It is so.
Okay. No problem. Yeah, continue. And Gokul, I haven't got your email ID. If you can ping me your email ID, I'll provide the access.
Sure.
Hi Satish. I registered. Could you please add me my email address?
Your name, sorry?
Ramakrishna.
Did you ping your email ID to me?
Sure.
Yeah, please ping. Yeah. Okay then. Okay. So we'll stop it here, guys. Yeah, please go ahead.
So in the syllabus, it is mentioned that introduction to Gen AI, LLMs, and use cases for performance testing and engineering. So what all things that you are going to cover in this?
As said, mentioned, it's about awareness and introduction. Okay. Nothing will not go anything in detail. Definitely, it is going to be one session, 1 hour session, where the objective is to introduce you to this what is Gen AI, what is large language model, what are small language models, what are the various use cases for which this generative AI is going to be useful in our performance testing or engineering. What are the current how we are using Gen AI in the projects. So those kind of discussion, it's about more of awareness and introduction. Will not go any further into the context engineering or into the prompt engineering and all at all. Okay, it's a very introduction is what we will cover it here.
Okay.
Yeah. See, this is an engineering course, but since it is these are very much in need, and everywhere they will be asking about you. So even though you answer performance engineering related questions in the interview, they will be testing your awareness and what you know about all this latest technology. So you should be aware of it. That is the intention of having this topic in the course.
And at the end of the course, are you going to share interview questions and answers for interview?
Yeah, not at the end, even at the beginning itself, right? I have it is there in the drive. Once you enroll, you will get access to the drive, and the drive will have those interview questions in the spreadsheet. Okay, I'll share it. It'll get shared right away once you get an access to the drive.
Okay.
So this, do we have a day-wise schedule, like from Monday, like what are the days, what are the topics?
I'll do it. I'll share it before the Monday. Okay.
Okay.
I'll share the tentative schedules for the rest of next at least next 2 weeks. I'll share it.
Thanks.
Okay. And over the weekend, please set up your questions. Yeah, please go ahead.
Yeah, so I have shared my email ID, Satish. If you can provide me access, that would be good.
Okay, sure, Hemant. I'll do it. Yeah. Your pinged it in the group itself,
WhatsApp,
correct?
yeah.
Okay. Sure. Yeah. Since you got 2 days of weekend, right? So making sure that you have this prerequisite and everything ready, whatever I told you, database and application, everything, so that it will be useful for you to follow it up from the Monday. Okay. We'll stop it again in the weekend. If you guys doing setup, if you have any problems, put it in the group chat. Okay. So when you put it in the group chat, right, others also will be able to answer it based on whatever they have got this problem. They would have solved the problem, and or I'll also help you out in fixing these things. Okay. So any issues you have it, put it in the group. Okay. We'll solve it together. Okay. And I'll stop the recording, guys. We will meet on Monday then.